Okay, so in these sections, we are talking about implicit differentiations. So what is an implicit function? Okay, so usually we have the function like 2x plus 3. This is what we call explicit function. That means it's a function depend on x only. However, when we have implicit functions, that means the function that is actually has y to the power 5 plus y plus x equal to 3, or y plus y to the cube equal to x squared plus 2. Now, these two functions right here, you will see that we will not be able to kind of solve for y, right? Okay, so therefore, again, this type of function is what we call implicit function then, okay? Or even like x squared plus y squared equal to 10, okay? Okay, equation of a circle is also is what we call implicit functions, okay? Anyway, so right now, if we have implicit functions, how do we actually take the derivative? Okay, so now you will see that before we do this section right here, we know how to take the derivative of a function if y is dependent on x only. However, some function like this one, we have a really hard time to solve for y. Okay, so we might be able to take the derivative. Yes, we could. We are going to use implicit differentiation then. Okay, so now let us think about this, okay? So the idea to do the implicit differentiation is we have to use the idea about the chain rule, okay? Now think about this. When we try to take the derivative of x, we know that in this case right here, basically we will take the derivative of x depend on x, right? So therefore, again, we know that this is actually is equal to 1. Kind of like we could simplify here, okay? However, if we want to take the derivative of y, well, in this case right here, we will have dy dx. Well, actually we could not solve for y, right? Or we could not simplify. So the derivative of y basically just y prime, okay? So therefore, in this case right here, if I want to take the derivative of y squared here, okay, then it's just like x squared, you know that is actually is 2y. But right now, this y right here is kind of like the inner function. So therefore, we are going to take the derivative of y then, okay, just like this. Maybe if you feel that, I have no idea what to do. Do you remember that how do we take the derivative of x squared? You know that is equal to 2x, right? Actually, the idea here is you could consider that this x right here is my inner functions. Then if I take the derivative of the inner function x, basically this is equal to 1. So therefore, the answer that I have is still 2x, okay? However, when we take the derivative of y squared right here, we will have 2y, and then the inner function is y. So therefore, the derivative of y is y prime. So therefore, the answer is 2y, y prime then, okay? So similarly, if I have y to the power 4, then in this case, I will have what? I will have 4y to the power 3, and the inner function is y, so I have y prime. Okay? So therefore, make sure that you remember, if you take the derivative of a function that involves y, then you also always have the y prime, this term right here. Okay, and now how about sine of y? Then I know that the derivative of sine is cosine of y and y prime. Yeah, okay. Now, a lot of students actually make the mistake when they take the derivative of x times y. They will feel that the derivative of x is 1, the derivative of y is y prime, so my answer is y prime. However, do you notice that this is actually a product, right? So if you have x times y, basically you have to apply the product rule. It's kind of like f times g. So it's f prime times g plus g prime times f, right? This is what we have. So therefore, the derivative of x times y, it is the derivative of x times y plus the derivative of y times x. Okay, so therefore the answer should be y plus x y prime then. Okay, yes. If you keep that in mind, then implicit differentiation is not that hard then. Okay, now here, how do we actually do the implicit differentiation now? We are going to differentiate both sides of the equation with respect to x. And then the next step is we algebraically isolate the term the dy dx then. Okay, so now let's look at our first example. Now to this example right here, I actually have an equation x squared plus y squared equal to 100. Okay, if you remember that basically this equation right here is a circle, right? Okay, with the radius is 10. Okay. Then in this case, I would like to find the dy dx at the point 6 and 8. So basically what I'm looking for here is, I'm looking for the slope of the tangent line at this point 6, 8 right here, okay, on the circle. Okay, then let's see how do we do this. Okay, now first of all, I have the function x squared plus y squared equal to 100. Then now what I'm going to do, I'm going to take the derivative with respect to x to both sides of the equation then. Okay, and then now you will see that the derivative of x squared is 2x plus the derivative of y squared is 2y, remember y prime, right, is equal to the derivative of 100 is just a constant, so it will be 0. Okay, then we are done with the step number 1. And then step number 2 is we would like to solve for dy dx now, which is y prime. So then in this case, I will have 2y y prime is equal to 2x. And y prime will be 2x over 2y, which is x over y. Okay. So, oh, wow, I have to be really careful about the sign then. Okay. Which is negative x over y. Okay. Okay. So then now, what do we have here is we are going to, again, now what we do, we are going to evaluate at 6, 8 then. So I'm going to have y prime evaluate at x equal to 6 and y equal to 8 now, okay? Then which is equal to negative 6 over 8, which is negative 3 over 4. So what does this mean? It means that the slope of this line, a tangent line at the point 8, 6, 8 is negative 3 over 4. Okay, well, that's it. Okay, so now it is your turn now to practice how do we actually find dy dx, okay, by implicit differentiations then. Okay, then let's start now. So I will have 2x to the 1/2 plus y to the 1/2 equal to 3. And then now what do? We take the derivative to both sides of the equation with respect to x. So I will have 2 times 1/2 x to the negative 1/2 plus 1/2 y to the negative 1/2 y prime equal to 0, right? Okay, and then now we are going to simplify this. So I will have x to the negative 1/2 plus, maybe let me write like this, 1 over 2 y to the 1/2 and y prime equal to 0, okay? Okay. And now, what do? Again, we are going to solve for y prime. So I will have, it will be y prime over 2 square root of y is equal to negative 1 over square root of x. And now I will have y prime is equal to negative 2 square root of y over square root of x. Okay. Or we could write it as negative 2 square root of y over x, something like this. Okay. Okay, then now, yeah, so this is actually is the idea. Okay, then let us work on number 3. Okay, now to this one, what we want to do is, again, remember we would like to take the derivative with respect to x both of the equations. But now you have to be careful about this term and this term because this is a product. So I know that the derivative of f times g, f prime g plus g prime f, right? Okay, and now let's try this then. So I will have 6x squared minus plus the derivative of x squared times y plus the derivative of y times x squared minus, okay, we subtract the whole thing. So I will have the derivative of x times y to the power 3 plus the derivative of y to the power 3 times x is equal to 0, right? And now let's simplify. Okay. And now remember the next step is we would like to solve for y prime. So the easy way to do this is we are going to group the y prime term, and then all other term as we move it to the other side of the equation then. So I will have x squared y prime minus 3x y squared y prime is equal to y to the power 3 minus 6x squared minus 2xy then. Okay. And of course, now we could factor the y prime. Okay. And of course, the last step is we solve for y prime. Yes. Okay. Okay. Now, number 4. Okay. Now, if you again try maybe pause the video and then work out the problem. Okay. Okay. So now I would like to take the derivative of e to the y sine of x plus derivative of mine equal to x plus xy. Okay. Okay. Then now remember it is a product. The derivative of e to the y times sine of x plus the derivative of sine of x times e to the y equal to the derivative of x plus the derivative of x times y plus the derivative of y times x, right? Okay. Okay. Okay, so now we have something like this. And then remember the next step is we are going to group all the y prime term. Okay, so I will have e to the y sine of x y prime minus x y prime equal to 1 plus y minus cosine of x e to the y then. Okay, or sometimes I just like to write it as e to the y cosine of x. Okay. Okay, then now we could take out the y prime. Okay, the last step, y prime is 1 plus y minus e to the y cosine of x all over e to the y sine of x minus x. Okay. Implicit differentiations. Okay. Okay, so now then maybe let us work on some problem. Okay, so now to this problem right here, we would like to use implicit differentiations to find an equations of the tangent line to the curve at a given point. Okay, so now remember, if we want to find a tangent line, the first step is we need to take the derivative. Okay, again, find y prime. The second is work with the slope of the tangent and point, right? Okay, so this is what we want to do. Then now we are going to take the derivative to both sides of the equations. Okay, okay. Then now the derivative of sine of x is the derivative of sine is cosine x plus y, and then we need to take the derivative of the inner functions, which is equal to 2 minus 2y prime. And then now I will have cosine of x plus y. Then here I have 1 plus y prime. Okay. So now, some of the students actually have a hard time to isolate this y prime right here. Okay. Now, to me, if you have a term multiplied to two terms, and then one of the term is the one that you want to solve, for example, like y prime. What I'm going to do is I'm going to distribute. Okay. So I will have cosine of x plus y plus cosine of x plus y, y prime. Okay. So I make it into two terms. And then now what we want to do is just a last problem, right? We group all the y prime terms together. So I will have cosine of x plus y, y prime, plus 2y prime is 2 minus cosine of x plus y. Okay. And then of course, now I will factor the y prime. Okay. Then the last step will be y prime is 2 minus cosine of x plus y over 2 plus cosine of x plus y then. Okay. Okay. Now, we are not done. We just want find y prime, right? We finished like a step number 1 here. And now what do we want to do? We are going to find the tangent line now. We know that the slope of the tangent is equal to y prime evaluated at x equal to pi and y equal to pi. And of course, the point is pi pi here, right? Okay, then now I would like to find the slope of the tangent at the point. Okay. Okay, so to this one, I will have 2 cosine of 2 pi basically is 1. So therefore, I have 1 over 3 now. Okay. Okay. Then now I have y prime is 1 over 3. Oh, let me use different color. So I have y prime is 1 over 3 at a point pi pi. Then I have y minus pi equal to 1/3 x minus pi. I know that by now you should be able to find the tangent line. Okay, so then this is my answer. Okay, this is the tangent line here. Okay, so now the next problem is I have an equation x squared minus xy plus y squared equal to 3 represent a rotated ellipse. Okay, now what is a rotated ellipse? Now normally we have an ellipse okay, the major axis is parallel to the x-axis or parallel to the y-axis. Okay, so this is a normal ellipse. The rotated ellipse is my major axis is not the x-axis or the y-axis or parallel to them. It actually is kind of like we have an angle. Okay, we rotate at some angle right here. Then we have an ellipse like this. Okay, so this is the idea about the rotated ellipse then. Okay, that is an ellipse whose axes are not parallel to the coordinate axis then. We would like to find a point at which this ellipse crosses the x-axis and show that the tangent line at these points are parallel. So therefore, to this problem right here, we need to, again, of course, we know that here. So we have the 2 points that is actually cross the x-axis. And of course, we will be able to, from these 2 points, and then what we want to do is, we would like to find the 2 tangent line at these 2 points right here. And then I have to show them they are parallel. Okay. So, meaning here is some step that we need to do. First, we need to find the x-intercept. Okay, this 2 points right here. Okay. And then, now remember, if we want to find the x-intercept, what do? We let y equal to 0, right? Yes. And then the second step is, we need to find y prime. And then, step number 3, we are going to have the find the y prime and then evaluate at the x-intercept then. Okay. And then try to see if they are the same then. Okay. So this is actually kind of like the idea what we need to do to this problem then. Okay. And hopefully that they are parallel or the result is the same. Okay. And now, of course, the first step is kind of easy. We want to find the x-intercept. So find x-intercept. So we let y equal to 0. So I have x squared minus x times 0 plus 0 squared equal to 3. So I have x squared is equal to 3, or x is plus or minus with 3 then. Easy, huh? Then the first step is we have the 2 x-intercept. The first x-intercept is negative with 3, 0. And then the second one will be with 3, 0 then. Okay. So we have negative with 3, 0. And then we have with 3, 0 here. And then now, the second step is we need to find the y prime now, right? So I have the second. We're looking for the y prime. So and now I take the derivative of x squared minus xy plus y squared equal to 3. Okay. Then it will be 2x minus the derivative of x times y plus the derivative of y times x plus 2y y prime equal to 0. Okay. Okay. Then now I have 2x minus y minus xy prime plus 2y y prime equal to 0. Okay, now we have to group all the y prime term together. So I will have 2y y prime minus xy prime equal to y minus 2x. So I have y prime is equal to y minus 2x over 2y minus x. Okay. Then step number 3, we are going to evaluate at the 2 points now, right? So then now let's try this. Step 3. So we would like to find the y prime at the x-intercept. Okay. Now I have y prime x equal to negative root 3, y equal to 0, equal to 0 minus 2 times negative root 3 over 2 times 0 minus negative root 3. So it's equal to 2. And x is root 3, y is 0. So I will have y is 0 minus 2 times root 3 over 2 times 0 minus root 3. Oh. Then they are the same, meaning what? The two tangent lines, they are parallel then. Since the slope of the tangent line at the x-intercept are the same, the two lines must be parallel. Okay. Okay. Then now the last one is actually a challenge question again. Okay. So what I would like you to do is I would like you to actually try to work on this problem and then check your answer later on. Okay. Okay. Now to this one right here, we need to work with the second derivative. Okay. So meaning I need to first find the first derivative, and then after the first derivative, then we work on the second derivative now. Okay. Okay. So then now let's try this. So I would like to take the derivative of x to the 1/2 plus y to the 1/2 equal to 1. And then now, of course, I will have 1/2 x to the negative 1/2 plus 1/2 y to the negative 1/2 y prime is equal to 0. So then, okay. And now I'm going to move this around. So I will have y prime over 2 square root of y equal to negative 1 over 2 root x. And of course, I have y prime is negative 2 square root of y over 2 square root of x, which is negative square root of y over x then. Okay. Okay, so then this is actually is what we have here. Okay. Then now, let us try to work on the second derivative now. So remember the second derivative, basically what we need to do is we need to take the first derivative, right? Okay. Then in this case, I will have take the derivative of square root of y over square root of x. Okay. Then now I will have negative of the derivative of y to the 1/2 times x to the 1/2 minus the derivative of x to the 1/2 times y to the 1/2 all over square root of x to the square. And now it is equal to negative. Now remember, this negative is negative of the whole thing. Okay, so I will have 1/2 y to the negative 1/2 y prime x to the 1/2 minus 1/2 x to the negative 1/2 y to the 1/2 over x. Okay. And now the question is, what is this y prime? Okay. So I'm going to have negative 1/2. Now this one right here, oh, maybe let me write like this. So I will have 1 over 2 square root of y times negative square root of y over square root of x times square root of x minus 1 over 2 times square root of x times square root of y. Okay. And now you will see that to this one, I have this one and this one cancel, and this cancel. Okay. Then I will have negative of negative 1/2 minus square root of y over 2 times square root of x all over x. Okay, so now we don't want to have a fraction over a number or over x, right? So what I'm going to do here is I would multiply both top and bottom by 2 square root of x, the LCD. And then now I will have this one is negative. Okay, so this one times this one, 2 and 2 cancel. So I have negative square root of x plus square root of y all over 2x square root of x. Oh, is it negative? Okay. And then now I would like to multiply this negative x. So I will have square root of x plus square root of y over 2x square root of x. Okay, now if you remember square root of x plus square root of y is equal to 1, then here you could plug it in, which is equal to 1 over 2x square root of x. Then. Okay. Again. So then this is my answer here. Okay. Okay, so that's it for this section, implicit differentiations. Okay, now remember the key is if we have implicit equations, we don't need to solve for y, okay, to take the derivative. We could actually just take the derivative to the equation right away. And then always remember, every time when you take the derivative that involve y, then you always have y prime. Okay? Okay. Then thank you.